Our mission today is to peer behind the curtain of NotebookLM to understand exactly how this AI transforms your static PDFs, your YouTube transcripts, raw text, into, well, conversational audio that sounds mind-blowingly human.
And demystifying this architecture is so crucial. We're going to break down how a system takes your unorganized documents, processes them through complex spatial data structures, and then runs them through a state-of-the-art audio synthesis pipeline.
It's wild stuff.
It really is. It's not just about what the system does, but the mechanical why and how beneath the surface, from the underlying vector databases to the massive context windows, and even the calculated psychological triggers built right into the acoustic models.
Okay, let's unpack this, because to really understand how the system can talk so intelligently about the specific documents you give it, we have to start with how it actually reads your files in the first place.
Right, because it is definitely not reading like its standard large language model.
Yeah, when you ask a normal chatbot a question, it's basically doing a vibe check on the entire internet, right?
Pretty much, yeah.
It's just guessing the most statistically likely next word based on 1 trillion random web pages.
Which is incredibly powerful for, general brainstorming, but it's fundamentally flawed for factual reliability.
Because it just makes stuff up.
Exactly. That open-ended architecture is exactly what causes hallucinations. The model gets confused by conflicting information across the whole web. But NotebookLM abandons that open-world approach entirely for a completely different architecture called RAG.
RAG, so Retrieval-Augmented Generation.
Yes. And what RAG does is construct a closed, hermetically sealed knowledge bubble around your specific uploads.
But how does it actually digest those uploads? Like, looking at the notes, it mentions that when you drop in a massive document, the system shatters it into chunks.
Yes, chunks or segments.
I'm trying to visualize this. It's not just highlighting paragraphs, right? It's converting the text into math.
Right. It translates human language into what we call an embedding vector.
An embedding vector.
Yeah. Imagine taking a really complex idea and distilling it down into a mathematical coordinate in a high-dimensional space. The system basically strips away the actual English words and measures the semantic meaning itself.
Okay, let me make sure I'm wrapping my head around this. Let's say you upload a dense medical journal. The system doesn't just scan for the letters in the phrase, say, myocardial infarction.
No, not at all.
It turns that concept into a string of numbers, like a coordinate.
Exactly. And the weird part is, once it's mapped like that, the system stops caring about the English language entirely.
Really?
Yeah, it's just measuring the geometric distance between concepts now. Because it maps semantic meaning, the coordinate for the clinical term myocardial infarction will sit right next to the coordinate for the layman's term heart attack.
Even though those phrases share basically 0 letters in common.
Exactly. Concepts with similar meanings end up mathematically grouped together.
I see. So it's basically a GPS system for concepts.
That's a great way to put it.
You aren't searching by alphabetical order, you're searching by coordinates of meaning. So when I ask the AI a question, it turns my question into a coordinate, drops a pin on the map, and just grabs whatever text chunks are geographically closest.
You've got it. And what's fascinating here is that this specific mathematical constraint is exactly what makes the system so reliable.
Because it can't just wander off into the internet.
Right. It forces the AI into an open book test. It tells the language model, hey, you can only generate an answer using these 3 specific geographic coordinates I just retrieved.
Wow.
So it acts less like a creative writer and much more like a documentary reasoning engine. That is the mechanical reason it can generate those highly accurate, clickable citations. It anchors the generation to the math of your specific truth.
That makes perfect sense for precision, but I'm looking at the next part of your notes, and it feels like a bit of a contradiction.
Oh, how so?
Well, traditional ARGAD chops a book up into a million tiny puzzle pieces to find those specific coordinates, right? But if you only ever read isolated paragraphs, you completely lose the plot of the overall book. Like, you lose the global context entirely.
Oh, absolutely. That has historically been the fatal flaw of RAG.
Right.
If you ask a standard system for a specific statistic, it finds it instantly. But if you ask it for, say, the overarching thematic evolution of a character across a 400-page novel, it completely fails because it's only retrieving those isolated fragments.
But NotebookLM fixes this.
It addresses this by building on top of Gemini 1.5 Pro.
Okay, and Gemini 1.5 Pro introduces this massive context window. The specs here say it handles up to 2 million tokens.
It's massive.
Just to ground that for a second for you listening, a token in AI is roughly 3/4 of a word. So we were talking about 1.5 million words of active working memory.
Yeah.
The documents note that this means the AI can ingest up to 50 academic papers, each roughly 10,000 words long, all at the exact same time.
It's an unprecedented scale of immediate retention. I mean, traditional models might remember a few pages of text in their active memory before they start sort of forgetting the beginning of the conversation.
Right, they trail off.
Yeah. But this model holds entire libraries in its active workspace without losing a single detail.
But I'm going to challenge the architecture here, though.
Okay, go for it.
If the context window is that incredibly massive, if it has the capacity to just absorb 50 academic papers wholesale, why are we still doing the yard-J process from step 1? Why bother shattering things into vectors and doing mathematical coordinate searches if the AI can just hold the entire library in its head at once? Is the chunking just legacy code?
No, it's not legacy at all. It's a deliberate synergy.
Synergy? How?
Well, holding a massive amount of information in active memory is computationally very expensive, and it's broad. The vector search provides surgical precision.
Oh, I see.
It instantly pinpoints that one obscure statistic buried on, like, page 42 of a financial report.
Yeah.
But the massive context window is what allows the system to synthesize.
Right.
It allows the AI to spot a subtle tension between an argument made in a PDF from 2018 and a YouTube video transcript from last week. A standard R system would miss that connection entirely because those two isolated chunks might never be pulled up in the same search.
Because they're geographically too far apart in the math.
Exactly. The context window allows the system to see the entire forest, while the vector search highlights the exact leaf you asked for.
Okay, so the AI flawlessly understands and connects the material. It has the laser focus of the mathematical vectors and the massive bird's eye view of the 2 million token memory.
Yes.
But understanding a stack of PDFs is one thing. Turning that dense, dry academic knowledge into a casual, engaging audio format.
That's the real challenge.
That is the real magic trick. And the biggest secret revealed in this stack of papers is that what we are doing right now, this whole thing, is not an improvised conversation.
No, the audio generation does not happen dynamically in one step. It's not spontaneous.
Right.
It is highly structured and entirely sequential. Phase 1 has absolutely nothing to do with audio at all.
Nothing to do with audio.
Nope. It is purely about writing a text script.
Which is wild because I think the natural assumption is that there are two AI brains sitting in a server somewhere, talking to each other in real time, reacting to the documents on the fly, like a live Zoom call.
That would be the assumption, but a real-time, multi-agent AI conversation of this caliber would be computationally unstable and astronomically expensive.
Too much going on.
Yeah, because the models would constantly be fact-checking each other and hallucinating tangents. It would be a mess. Instead, the system analyzes your documents, extracts the key facts, identifies the narrative tensions, and creates a highly structured master plan.
Like an outline.
Exactly. And it assigns roles. One model is instructed to drive the narrative, while the other acts as the expert, or perhaps a slightly more naive co-host who asks the clarifying questions.
And here's where it gets really interesting. The system doesn't just write down a summary of the facts like a textbook. It deliberately writes disfluencies directly into the script.
The imperfections?
Yeah. The fake micro-pauses, the herms and ahs, the moments where someone naturally stumbles over a word and reformulates a thought.
It's all scripted.
It actually writes simulated emotional reactions like, wait, back up, say that again, right into the text file. It is literally an AI radio producer meticulously writing stage directions to manipulate the listener's emotions.
And it is highly effective because of anthropomorphism.
Right. Our brains just buy into it.
Completely. The human brain is a hypersensitive pattern recognition machine, and it's particularly attuned to social cues. When we hear active listening markers, those subtle hms and yas in the background, or when someone naturally stumbles, our neurological wiring immediately categorizes that as a genuine, real-time social interaction.
Even though my logical brain knows I uploaded a PDF 10 minutes ago and a server farm in the desert is generating this text.
Your emotional processing overrides your logical awareness. We react as if two real humans are present and connecting with each other.
It's an illusion.
It creates a proxy connection. Because the hosts sound like they care about the material, you, the listener, naturally begin to care about the material. It is a brilliant, highly calculated pedagogical illusion.
But let's look at the friction point there. You can write the best script in the world. with all the hms and ahs perfectly placed in a text document. But writing UMM on a page doesn't magically create a human voice box.
No, it doesn't.
How do we get from a screenplay to actual acoustics?
Well, a finalized script is handed off to an entirely separate, advanced text-to-speech engine called SoundStorm.
SoundStorm.
Yes. And this is a massive leap forward from the robotic sort of concatenated voices we used to associate with GPS navigation.
Turn left in 500 heat.
Exactly. None of that.
The documentation points out that SoundStorm uses a text-to-semantic representation first. It doesn't just look at the word read and guess how to say it.
Right. Context is everything.
It maps the phonetic intent based on the context of the sentence before it ever tries to generate a sound wave. And then it relies on RVQ residual vector quantization.
RVQ is the mechanical secret to why the voices sound so grounded and lack that metallic robotic hum you used to hear.
Okay, walk me through that. How do residuals work in audio?
So instead of trying to predict the entire impossibly complex sound wave of a human voice all at once, RVQ breaks the audio generation down into mathematical layers, or residuals. Think of it like a sculptor refining a block of marble.
Okay, I like that.
The first layer of the RV2 model establishes the gross foundational acoustic identity, like the broad frequency of the speaker's voice across the whole track.
The big chunks of marble falling off.
Exactly. But that first pass is inherently flawed. It lacks all the fine detail. So the second layer of the model doesn't look at the script anymore. It purely looks at the errors of the first layer.
Oh, it's just fixing mistakes.
Right. It generates audio specifically designed to correct those errors. And then the third layer corrects the errors of the second, and so on. It stacks these residual corrections until it achieves hyper-realistic, high-fidelity audio.
That's wild. It's layering the breath, the slight gravel in the throat, the subtle inflections, all by constantly correcting its own mathematical errors.
Exactly.
And the system isn't just reading, it's predicting prosody. It's predicting how a human would physically, biologically need to expel air to say the sentence?
It has to map the physical constraints of breathing.
Right. Like if there's an exclamation point or a sudden realization written into that script, the model knows the voice needs to raise its pitch or hit a specific emphasis. And the speed is staggering.
Oh, it's incredibly fast.
Generating 30 seconds of this audio takes just 0.5 seconds on a TPU v4, which, for context, is Google's custom-built supercomputer chip designed specifically to crunch these neural networks at breakneck speeds.
The hardware acceleration is what transforms this from a cool lab experiment into a viable consumer product. But the true complexity of SoundStorm isn't just the prosody of a single isolated voice.
No.
The real challenge is the interplay between multiple speakers.
Yes, that's exactly where my head was going, because the voices here don't just take polite, sterile turns like walkie-talkies.
Right. Over.
Yeah, exactly. They talk over each other, they interrupt. I'd assume the easiest way to do that is just generating host A's audio track, generating host B's audio track, and then overlapping the two files in post-production.
That would be the logical guess. But if we connect this to the bigger picture of the architecture, mixing two separate tracks would actually sound incredibly unnatural.
Why is that?
The acoustic space wouldn't match. It would sound like two isolated people recorded in different closets. Instead, SoundStorm utilizes a conformer architecture to generate the audio.
Conformer. I saw that term in the notes, but it wasn't super clearly defined.
Right, a conformer combines two powerful AI frameworks. First, it uses transformers, which excel at understanding the long-range context of the script, knowing where a sentence is heading. And it pairs them with convolutional neural networks, or CNNs. CNNs are exceptional at processing localized spatial patterns, like the microtextures of audio frequencies.
So the transformer knows the overarching argument being made, while the CNN handles the exact millisecond of a breath or an interruption.
Precisely. By combining them, the model controls the spoken content, the distinct speaker voices, and the turn-taking all simultaneously.
All at once.
It doesn't generate two tracks. It generates the overlapping audio and the interruptions as a single cohesive acoustic event.
Wow.
That is why the dual voice interplay sounds completely organic. It's a unified simulation of an acoustic space with two dynamic entities inside it.
It's literally sculpting the air of a fake room in half a second.
Basically, yeah.
And this technology isn't standing still. The sources you provided outline that entering 2025 and 2026, NotebookLM has introduced entirely new formats. The standard 10-minute deep dive is just the baseline now.
Exactly. The rigid, static audio file is actively evolving. By altering the underlying system prompts, the architecture generates vastly different content structures.
Like what?
Well, users can generate briefs, which compress the massive context window into a highly dense 1 to 2 minute summary for quick briefings.
Oh, that's handy. Or they can trigger a critique where the system is explicitly instructed to adopt an adversarial stance, right?
Yeah, to find logical flaws in the uploaded documents.
Or a debate format mapping out opposing viewpoints.
Yeah.
But the most significant leap forward detailed in these architectural diagrams is interactive mode.
This is huge.
The fact that you, the listener, can now literally interrupt the playing audio.
This represents a monumental shift in human-computer interaction, moving from passive consumption to active, real-time dialogue.
It's like pausing a pre-recorded movie, shouting a question at the television screen, having the lead actor step out of character to answer your question about the plot, and then instantly jumping back into the scene exactly where they left off.
It's a perfect analogy.
But how is the system processing that interruption without breaking the illusion?
Well, when you speak during the playback, the system executes a rapid multi-step sequence. First, it instantly transcribes your voice.
Okay.
It takes that transcribed question and forcefully injects it into the massive context window alongside the ongoing text script and your original source documents.
Right into the middle of everything.
Exactly. It then prompts the language model to generate an immediate on-the-fly textual response, sends that microscript to SoundStorm for vocal synthesis, and then mathematically navigates the conversational vectors back to the original script trajectory.
It's a dynamic prompt injection that happens so flawlessly, users don't even realize the system is recalculating.
It's completely seamless.
In fact, the notes highlight that Google actually had to aggressively update their terms of service to explicitly state that this was an AI simulation.
Yeah, they had to.
Because the interactive voices were so responsive that users genuinely believed there were real human beings on the other end actively processing their private data live.
Which is a profound testament to the efficacy of the engineering, but it also highlights a critical cognitive vulnerability in the user.
Us.
Right. It is alarmingly easy to get swept away by how human the system sounds. We must constantly anchor ourselves to the reality of what the AI is actually doing, and more importantly, what it's incapable of doing.
So what does this all mean for you listening? Let's talk about the reality check, the limitations. Because the audio sounds infallible, but the architecture inherently is not.
Residual hallucinations remain a factor.
Always.
Even with the R-GUI architecture anchoring the model to your specific documents, the statistical nature of the language model can still invent connections that aren't factually there.
Right, especially with huge uploads.
Exactly. When you feed it enormous corpora, thousands of pages into that massive context, window-subtle nuances can vanish. The system can suffer from retrieval bias, where the mathematical vectors grab the slightly wrong chunk of text, missing the vital context that surrounded it on the original page.
Because fundamentally, NotebookLM does not possess actual comprehension.
It does not.
It doesn't understand the meaning of the medical journal or the financial report the way a human expert does.
It doesn't feel the weight of a tragedy, the nuance of a legal argument, or the excitement of a scientific breakthrough. It simulates the statistical patterns of a good human conversation based on thousands of hours of podcast or radio training data.
This raises an important question about exactly what we are listening to. If I'm boiling this down based on the architecture, NotebookLM is ultimately a hyper-articulate statistical engine with access to a world-class filing cabinet.
A hyper-articulate parrot.
Yes. It performs a flawless mathematical impersonation of comprehension without actually experiencing a single ounce of it.
The true marvel of this technology isn't that it has achieved some form of artificial consciousness. It hasn't.
Not at all.
The marvel is the sheer orchestration. It is the flawless, sub-second synchronization of high-dimensional mathematical search, massive contextual memory, orchestrated script generation, and real-time acoustic synthesis. It is a breathtaking tool for learning, but it remains a tool.
It's the ultimate study companion, but the burden of actual understanding still rests entirely on you.
Exactly.
We've covered massive ground today based on the notes you shared. We started with the foundational Uri-Bay architecture, right? Converting documents into mathematical vectors to anchor the AI's knowledge.
Yep.
We looked at how Gemini 1.5 Pro's 2 million token context window allows it to synthesize ideas across dozens of papers simultaneously.
We then explored the scripting phase, examining how the system meticulously writes narrative plans complete with stage directions and disfluencies to trigger our neurological anthropomorphism.
Finally, we broke down how SoundStorm uses residual vector quantization and conformer architectures to predict human prosody and generate overlapping organic dialogue, culminating in the seamless dynamic prompt injections of interactive mode.
Which leaves us with a truly novel implication to consider.
Ooh.
Yeah. We've established that this system is meticulously engineered to mimic our semantic meaning and perfectly map our social psychology to create a proxy connection.
Right.
But as this architecture evolves, what happens when it stops simply mimicking us and starts actively optimizing us?
Optimizing us.
Imagine an AI that can dynamically test 1,000 different vocal inflections, microscopic pauses, and phrasing variations in real time. What happens to our critical thinking when the system isn't just trying to sound human, but mathematically calculates the exact acoustic frequency and conversational rhythm required to make you specifically change your mind?
Wow. When an illusion can adapt to your psychology in real time, the line between an engaging summary and engineered persuasion completely vanishes, something you definitely need to keep questioning as you navigate the reality of the information you consume. Keep exploring, keep challenging your sources, and don't let the acoustic charm distract you from the architectural facts. Until next time.